Hello, everyone. Welcome to the third video of factor analysis class. In this video, we're going to conduct factor analysis, particularly the exploratory factor analysis using SPSS. So let's get started. Let me share the screen with you as always. Okay. So I hope everyone can see my screen right now. So for factor analysis, as we mentioned in previous video, it is quite different from principal component analysis because the goal of factor analysis is not to reduce dimension. Rather, it is to find the latent variables. And a latent variable is a conceptual construct which cannot be observed directly, but can be measured by other observable variables. Usually we will use multiple variables to measure or to induce or to reflect the construct. As we show, the example of IQ measurement in video 1. Okay, in this hands-on example, we're going to use the data from SPSS anxiety questionnaire. So this data is also from UCLA Statistical Methods and Data Analytics class. It's an open source online class. It's totally free. And this so-called SAQ is a hypothetical experiment. So the experiment doesn't exist, okay? And the value not meaningful for anything. It's just created by Andy Field. Okay, I believe he might be some guy work for SPSS. I don't remember. I'm sorry for that. But this guy, create this hypothetical experiment and create this kind of data. So we are going to use this data as for illustration purpose, so that we can understand the factor analysis. Okay. So before we go to factor analysis operations in SPSS, we still need to recall some theoretical background of factor analysis. As we mentioned in the first video, there are usually two major factor analysis. One is called exploratory, the other is called confirmatory, right? And confirmatory factor analysis will be discussed in week 9 together with structural equation model. And in this video, we're going to do the exploratory factor analysis, i.e. EFA, okay? So through EFA, we are not assuming any theoretical support, structure between the factor and independent variables. We try to explore the potential construct to support some factor through several unknown relationship, but known observable independent variables. Okay, similar to PCA, the original regression model should be y equal to beta 0 plus beta 1 x1 until beta n xn. And instead of using, as we mentioned, instead of using PC equals a combination of independent variables, we assume each independent variable is a combination of different factors, so different unknown latent variables, plus a system error. This is different from PC because there is no system error here, but it should have some. And we also see m latent variable is less than n, the number of current variables. Okay, so in practice, it's still a dimension reduction, but the logic reasoning behind is not to reduce the dimension, but to find the construct or so-called factor. Okay, as we know, after lots of mathematical operation, we convert the format of the regression model from y related to x into y related to f. Okay, the factors. Okay, how can we conduct factor analysis in SPSS? First, we still need to open the data. Okay, this time we try to use a different way to open the data. So If you download this data as AQ from Canvas, you should have this file somewhere in your laptop or in your personal computer. Last time we opened SPSS first, then load the data, right? This time just double click this data. If you have already installed the SPSS, it will automatically open by the SPSS. So let's double click it. After a few while, yeah, we see, the question is here, okay? There are 23 questions here, okay? And see the data view also. We can see all those questions are in Likert scale from 1 through 5, okay, 1 through 5. And data view. And in the label column, we can see the meaning of each question, right? Let me see the value. 1, strong agree. 5, strong disagree. Oh, we have a 9. I'm sorry, I have a 9, not an answer. So it's different, it's different from what I saw in the previous teaching evaluation. But since it's two different samples, it's hard to say whether the previous one have the same setting of the Likert scale here. It could be reversible. So here 1 is agree and 5 is not agree, okay? So here the fabricated, value. So after that, we need to conduct a factor analysis, okay? How can we do that? Go to analysis, still the same, dimension reduction and factor. All the same, to PCA. And let's select, all the variable that we think we need to find the construct, right? So select all the variables, move it to variables, okay? Descriptive. We still need initial solution just for, to see the difference here. We also check the coefficient and KMO, okay? That's, testing, still remember KMO? Testing, whether the sample size is sufficiently large to do the test, okay? And Ballard's test is to test whether the correlation matrix is identity matrix. The identity matrix, okay? And extraction, we still need a script plot, okay? And we still try to, based on eigenvalue, okay? But method is no longer a principal component. Instead, we'll use principal axis factoring. Okay, principal axis factoring. This is for factor analysis, okay? And iteration, here is still 25, but in case it cannot converge, let's put 100 here, okay? And continue. And still rotation, okay? In the previous one, we said for principal component, we try to make every principal to be orthogonal with each other. That means the correlation should be 0, right? But in factor analysis, that is not the case. And so instead of using, Varimax, we try to use direct complement. So it usually refers to some correlation between the factors. Can we use Quadramatrix, Quadramax? Can we use Equalmax? Can we use Promax? It depends. So you need to check the manual to see the meaning of each rotation, but they all have, correlation between factors. Let's just choose this one, okay? And similarly, we need to check the loading units and continue. For the score, still save the scores as regression, so we can see the coefficients and options. Still sort by size, suppress small coefficient, and still let's set everything smaller than 0.3 should be ignored because the correlation is too weak. Continue. And everything else same. Click OK. Okay. It's running factor analysis. Okay. So similarly, that will give us a correlation matrix. Okay, so in this case, it should be 22 or 24 something. The questionnaire, the answers, right? Still, we have a KMO and Bartlett test. A KMO test gave us a 0.93, which is greater than 0.6. So that means the sample size is sufficiently large. And we can see the significance of Pauli test is 0, 0, 0. So reject the null hypothesis. So the correlation matrix is not identity matrix. Okay, so it's not 1, 1, 1, 0, 0, 0. Okay, so that means there are some correlation between independent variables. So they are not really independent. Okay. Similarly, as communalities, is try to the percentage of variance of this independent variable. Okay. Explained by other factors. So remember, so the first one, I see the initial is no longer 1 anymore, because in the previous one, in principal component analysis, we suppose we assume every principle is orthogonal with each other. So all the variances about themselves, it's just all about the common variance, right? It's nothing specific to the variable itself. But here, because of such assumption, we have common and specific variance. Excuse me. So the initial is different. But after extraction, this one should be the end result. After we find the latent variables, we find the construct. The correlation, the number of the percentage of variance explained by those construct. Similarly, for the total variance, it's the percentage of the variance explained by the construct. Here we see we have 4 factors instead of 2 components in the PCA in last video. In this example, we have 4 factors, and the cumulative loadings is 40.47%. We can see it's like less than 50%. So does it mean it's not a good representation? It's not necessarily, okay, because it's different from PCA. As we remember, in PCA is a combination of X, but in FA, X is a combination of F. So now we are using F to represent X. There should be something missing in the random error. So the goal is not to find the exact percentage of the variance. The goal is to test whether those 4 factors are valid or not. How can we do that? We'll do a reliability test after that. Okay, we'll introduce later. So currently we have the cumulative of 40.5% of variance explained by those 4 factors, which is not so bad. It's still 40 something, but the larger the better, right? So here, similarly, we have a script plot, and we can find, when the number, number of factors become 4 is still greater than 1, so it's still a good, choice. So why still eigenvalue here? Because in SPSS, it still use PCA's way to determine, the number of factors, because we haven't seen anything there. But in other programming or statistical packages, for example, if you are doing R, it will use a different way to show which number is better, okay? But the result should be consistent. So if PCA give you 4, the other analysis should give you 4 too. So here, factor analysis. So factor matrix. So remember, we have X equals to a set of alpha and F's. So those are alphas here, okay? And these are not rotated. So pre-rotation alphas are those things. It reflects the relationship between the X and F, okay? As we know, you see, factor 1 consists almost every question except for the last 4, but we know it's because they are less than 0.3. It doesn't mean they are 0, okay? Similarly, 2 and 3 can only, a construct of the other several questions. And, factor 4 is like empty. Why empty? Because everything here is like, less than 0.3. But why we still keep this factor 4? Based on script plot, factor 4 is optimal. So without rotation, this matrix shows something quite weird. That's why we still need rotation for in factor analysis. So after rotation, we get this pattern matrix. Okay, pattern matrix is rotated factor matrix. The loadings here are still the alphas, but the rotated alphas. It's not the original alphas. So in this pattern matrix, we can see factor one, can be measured by this set of questions. Okay, factor two can be measured by this set of questions. Factor three can be measured by this set of questions. Factor four can be measured by the last three set of questions. Let's see what is factor four. Factor four is about I have never been good at math. I did badly in math. I salute a call whenever I see an equation. So factor four might be someone, just aversion against math, right? Personal taste, something like that. Just doesn't like math. Okay. So that's factor. So that's a construct. Okay. They share something, right? Something might be do you like math, right? It could be IQ. It could be something like do you like math. You can use a question, do you like math, to measure this. But here you have three questions to measure the preference to or against math, right? It's a personal preference. So personal preference is really difficult to measure. Okay. But you can use 201. So, but in this case, in this example, just for illustration purpose, those three questions reflect a concept, a construct, or a factor preference against all math, right? Let me have other thing here. So after rotation through a pattern matrix, we can find the four factor, right, to represent, not to represent all those independent variables, reflect four factors, four latent variables here. Okay, that's the result. So as we can see in our final result here, in our tutorial, okay. So this is the final result we can get, okay. But our purpose is not to, to reduce the dimension. We try to see now that we can, group these 22 or 24 independent variable into four latent variables, four concepts, four construct. Are those grouping, are those reflection reasonable, right? Then this is called Cronbach test. Okay, Cronbach alpha test. Okay. So a Cronbach alpha test is a test about internal consistency in a group, which means if we use the last three questions to measure the concept, the construct, factor four, is it good or bad, right? Are those three questions consistent with each other? Internal consistency, right? We'll try to test the Cronbach alpha test. The mathematical formula of this Cronbach test is not necessarily to introduce here. If you are interested, you can Google it online. But we are in a PA major, we don't have to dig so detailed about that. We just understand we can do that in SPSS. But the trick part is still is the thing I mentioned. In SPSS, the result of pattern matrix is shown in label, not the name of variables. So for example, if we try to test the consistency of factor one, we need to find the corresponding variables here, right? Then we conduct the scalable, the Cronbach test, alpha test, right? So in this example, I am so friendly to summarize, to locate the variable for you guys. So for construct one, we have Q1, Q3, Q4, Q5, Q12, and Q16, Q20, 21. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 variables to measure factor one. This measure, good or bad, right? Let's do it. Okay, let's do a Cronbach alpha test. How can we do that? It's in analysis, scale, reliability analysis, okay? Then let's select the variables we need for factor one. You see here still label. It's difficult to tell which one's which, right? And you can match the labels. That's depends on your choice. That depends on choice. But now that I've already find the variable name, we can change it to variable name. So just right click this, okay, right click, display variable names, okay. It will show variable names, okay. Let's see what else we have, okay. Q1, 3, 4, 5. Okay, let's first select 1, 3, 4, 5. Okay. 1, 2 item, not 2 ratings. Okay, 3, 4, 5. Okay. And what else? 12, 16, 20, 21. Okay. 12, 16, 20, 21. Right? Then what? Alpha is a default, so don't need to check anything. Statistics, you don't need anything else. You don't need anything here. So just keep it as default and click OK. Okay. We'll show you here, okay, reliability statistics, Krabash alpha, which is 0.605. As a rule of thumb, everything bigger than 0.7, which means a good consistency. So 0.6 is close to 0.7, but not close enough. So this construct is questionable, maybe not. So we don't know about that. So let's see what's the result for construct one. Wake up under my dual thinking that I am trapped, something like that. I can't sleep without for thoughts of argument value. We've openly as a mesh of central tendency, okay? It's like hate normal distribution, don't know about argument value, no basic statistic thing, Pearson's basic statistic thing, standard deviation, basic statistics. Statistics makes me cry. I don't know, maybe people try to tell you that SPSS makes statistics easier to understand, but it doesn't. So that's kind of a mix. It's like something, related to not liking statistics, or something like not, doesn't like SPSS. Some like just a, fear of statistics, right? And the fourth one is like math, so it's kind of a mix. So it's understandable, right? Now that we test factor one, we don't need to test factor two and factor three. Even though I list you those factors, you can test yourself. Okay. I've already shown the result of each test in the auto tutorial. Okay, so you can see factor two, factor three. Let's test factor four. Okay, for just for fun. Okay, so test four. Let me see. Q8, 11, 17 to construct test four. Okay, factor four. I'm sorry. So still analyze, scale, reliability analysis. Instead of this, let's select all of them, move back. So what's that? I have very bad memory. So 8, 11, 17. Okay, 8, 11, 17. 8, 11, 17. 8, 11, 17. Okay, everything have default and just click OK. It gave us, okay, see, 0.819, which is greater than 0.7, which means this construct is valid. It's very good. So like we said, the construct of 4 is measured by 3 questions. Never good at math, badly in math, slip into a comma when see an equation, right? When see an equation, yes. So it's kind of a fear of math, of bad at math. That might be the construct there, right? You can do it for factor 2 and factor 3. Okay, So that will be end the reliability test for factor analysis. So we can see the end result of factor analysis is not really, well, the end result of factor analysis does not stop at the coefficients, those, above, sorry. The rotated coefficients, right? It's not about a combination of, X is a combination of F. That's not that meaningful, okay? But we need that pattern matrix to see how those latent variable construct by those, observed variable or measures, and how well this kind of combination is a good construct, how well those questions to measure this, factor. We're using the Cronbush alpha test. So this kind of Cronbush alpha test can be seen as a good measure, or can be seen as part of the result. So it's the reliability test plus this pattern matrix. Okay, I think that'll be it for factor analysis. I hope you guys can practice this at home. And if you have any questions, feel free to send me an email. We'll see you in Tuesday night. Okay. Let's close it.